What's up, everybody? Today we are solving LeetCode problem 33, search and rotated sorted array. So basically the array is rotated left to some random amount of time, and you're basically supposed to find some solution to find a target number in O log n, and that pretty much always just points to binary search. And you're probably thinking, whoa, this array is rotated. How am I supposed to perform some binary search action on this junt? I got you. So let's just use this example that's given right here. You search for 4567012 in 4, and right here I already got it drawn up here. So, if you know your regular binary search, you got your left pointer and your right pointer right here, and you got the middle pointer right here. So let's say, we're searching for 4, right? This is where the middle pointer would be. And if you look right here, there's a very important fact that we can leverage. So the fact that you can leverage is that is left less than m. Is nums L less than nums m? The reason why that's so important is because you're able to know whether or not you should go left or right in order to find where your target number is. And stay with me here. For example, let's say that, in this case, left is less than m. When that's true, everything in this area is sorted. And let's say our target number is 0, right? Let's say we're looking for this bad boy right here, right? And nums L is less than nums M. We just know that, right? This is sorted, and we know that. So how do I know that I got to go towards the right to look for 0? Okay. Basically, since this is rotated, we know for a fact that all values, since L is less than M, we know that all values that are less than left is on the right side. We just know that because this is sorted, correct? And let's say that we're looking for 4, right? Just like the problem asks. Since we know that our value is in between the range of 4 and 6. If it's not in between, if the target is not in between the range of 4 and 6, then you got to go that way. But then you're probably asking, wait, what if L is not less than nums M? Like, let's say our middle pointer is like right here. Look at that. Left is greater than M now. And it's like, whoa, what do I do then? Boom, another fact you can leverage. What you now may have observed is that this part is now sorted. No matter where, as long as M is less than L, nums M is less than L, anywhere here, again, from the middle pointer, it will always be sorted. From the middle pointer towards left or right, it'll always be sorted, and that is what you leverage. So let's say the middle pointer is here for whatever reason, and you're thinking like, okay, now I'm looking for 4. Which in the possible way could that be? It's greater than R, so that means I go that way. Boom, just like that. And in that way, you perform your standard binary search action with that type of logic. Hope that made sense. I know that was pretty insane. Just study up your regular binary search and then try to understand what I was trying to say right here. If you have any questions, please leave them in the comments. I'm more than happy to answer. But let's get to coding. Okay, let's code up our solution now. So obviously, you know, regular binary search action, you got your L comma R is equal to 0 comma length of the array minus 1, while L is less than or equal to R. M, the middle is L plus R for division 2. You check if you found your target. Turn M, and now we get into that good stuff. So like I said right here, you first want to check which part of the array do you know for a fact is sorted and can leverage. So first we're going to check since this with this input is left less than M, less than or equal to M, then you know for a fact that you're in the left sorted portion of the array. You know for a fact that from nums L to M it is sorted, right? So you can leverage that is nums L less than or equal to nums M. If that's true, you know where you're at. And then boom, since you know that this is that sorted action, now you want to know, do I stay in here? Do I bring this R pointer here and then bring that middle, obviously, you know, wherever, here or whatever, or do I pull the L forward and then put the middle over here to find my target? So you would have to check, is my target within this range or not? If it's not, then you know whatever you're looking for is in this range, if that makes sense. So let's check for that. We will do if target is greater than or equal to nums L, while also being less than nums M. If that's the case, then you know for a fact that you can pull your right pointer back to you. Because if you know that whatever you're looking for is greater than 4 while also being less than M, you know you can pull your R in here because you know that whatever you're looking for is in this range. Else, you do a little L is equal to M plus 1 action, right? And now we're going to check if we're, for some reason, your mid-pointer is like here. So now you know for a fact that L is not less than M. So you know that this part is sorted, and you can leverage that to find wherever your target value is. So you do else if target is greater than nums M and target is less than or equal to nums R. See what I'm doing? I'm checking if target is greater than nums M while also being less than nums R. So now I know for a fact that if that's true, whatever I'm looking for is right up in here. And since I know that's the case, I would just do L is equal to M plus 1. Boom, pull that left pointer forward, else R is equal to M minus 1. And if it breaks out, then obviously whatever you're looking for does not exist. Run that bad boy up. Boom. Let's submit it. Bang! 0 milliseconds, bro. All right. Hope you guys enjoyed this video and learned something from this, because this is an incredible problem and it'll make you really good at binary search. Thank you. Please like and subscribe.